Hello student, welcome back in today's lecture of oscillation. In this lecture, we will start here the simple pendulum. What is simple pendulum? We have to calculate here the period of a simple pendulum. And here we have to show here the motion of a bob of a simple pendulum is simple harmonic motion. Means when this pendulum is oscillate, then its motion is oscillatory or vibratory. There is a simple harmonic motion. So, the arrangement like this. This is a rigid support. This is a light and inextensible string. This is point of suspension O. Here the heavy sphere, small heavy sphere is like that here. This is the center of gravity of a bob, A point. OA is the equilibrium position here. This OA distance is known as the length of the simple pendulum here. Now what is simple pendulum? This is rigid support here. This O is the point of suspension. A is the center of gravity of a bob. Now what is simple pendulum here? The practical simple pendulum. We use in practical purpose practical simple pendulum. What is practical simple pendulum here? The practical simple pendulum is a pendulum which consists of a small heavy sphere, ज्याला आपण bob म्हणतो. It is a small heavy sphere suspended by light and inextensible string from a rigid support. Light and inextensible string from a rigid support. असं मी म्हटलेलं. Inextensible string means it is unable to stretch. That is called as the inextensible. What is simple pendulum here? Simple pendulum is defined as, what is simple pendulum? Simple pendulum is defined as a heavy sphere. This is called as the bob also. A heavy sphere suspended from a light and inextensible string from a rigid support. That is called as the simple pendulum. Now, if this bob is displaced now from the mean position, या बॉबला जर आता आपण त्याच्या मेन पोझिशन पासून OA त्याला आपण मेन पोझिशन म्हटलं, त्याला आपण डिस्प्लेस केलं तर तो इकडे गेला. त्याची पोझिशन B दाखवू आपण. दिस इज B टू A आला परत इथे डिस्प्लेस झाला तो, असा डिस्प्लेस होईल तो. This is position C here. This becomes now the semi-vertical angle theta here. If this bob is displaced from its mean position, OA पासून तो displaced झाला, तिथे angular displacement theta form केला. Let theta be the angular displacement here, and this becomes arc here, and this displacement is A to B. This displacement is x here. Okay. Now What is simple pendulum here? This is the simple pendulum. Here we have to show that the motion of a bob of a simple pendulum is a simple harmonic motion, and also find its time period. Time period पण काढायचा आहे. So for this, here this OA, this is called as the length of the simple pendulum. What is length of the simple pendulum here? The distance between the point of suspension O and the center of gravity of a bob. This is called as the length of the simple pendulum. Now, if this pendulum is displaced from its mean position or equilibrium position, then it is displaced to this extreme point. This is B or C. This is moved on the either side of this mean position. This B and C are the extreme position here. If this bob is displaced in any position of a bob, either this position is B or C, in any position of a bob, the two types of forces are acting on a bob. त्या बॉबवर दोन प्रकारचे फोर्सेस ऍक्ट होईल. एक म्हणजे द फोर्स ऍक्टिंग vertically downward direction. When the bob is displaced from its mean position, the two types of forces are acting on a bob. The first force is its weight mg acting vertically downward direction, ज्याला आपण इथे gravitational force म्हणतो. And the second force is the tension capital T dash in the string, which is moving along BO from a rigid support. बघा काय म्हटलं आपण की in any position of a bob, in any position of a bob, either B or C, that is the extreme position, ज्याला extreme position म्हणूया आपण. In any position of a bob, the two forces are acting on a bob. The two forces are acting on a bob. कुठले कुठले आहेत? Number 1, the weight mg of a bob, weight mg acting vertically downward direction, ज्यालाच आपण कुठला फोर्स म्हणूया? ग्रॅव्हिटेशनल फोर्स. And second force is the tension T dash acting along the string. जे कसं मूव होत आहे? इट इज अलॉंग BO. अशा दोन प्रकारच्या फोर्सेस इथे एक्झर्ट्स होईल. आता इथे ते दोन प्रकारचे फोर्सेस जेव्हा एक्झर्ट झाले, कुठले कुठले? द वेट mg ऑफ अ बॉब ऍक्टिंग व्हर्टिकली डाउनवर्ड डायरेक्शन अँड टेन्शन T dash in the string, which is moving along BO, that is from the rigid support. Okay, here this bob is balanced at the extreme position, either this or this. तो बॅलन्स कशामुळे आहे? तो बॅलन्स हा mg चे जे दोन कंपोनेंट राहील याच्यामुळे तो बॅलन्स राहील. सो हियर दिस mg कॅन रिझॉल्व, हा जो फोर्स आहे द वेट mg of a bob can be resolved म्हणजे divide, resolved into two components. दोन components कुठले कुठले राहिला त्याचे? एक म्हणजे mg cos theta, this is the first component. That is mg cos theta. This is theta here. This is mg cos theta along the string, and second component is mg sin theta. जो कसा आहे, it is perpendicular to the string. Here at the extreme position B, this mg, weight of a bob mg, this can be resolved into two components. First कोणता आहे, mg cos theta. This is the कुठला component झाला तो, this is the mg cos theta along the string, along the string, along the string. This is known as the radial component here. And second one is mg sin theta, जो कसा है, perpendicular to the string. mg sin theta which is perpendicular to the string. Okay, so the component mg cos theta is balanced here. कशामुळे balance आहे? Due to the weight mg. But the component mg sin theta is not balanced. So to restore the bob from B to A, from extreme position to mean position, बॉबला रिस्टोर करायचं आहे, जागेवर जायचं आहे. So the restoring force is acting on a bob. त्या बॉबवर काय होईल तिथे, the restoring force is acting on a bob, and that restoring force is nothing but the component mg sin theta. त्याला निगेटिव्ह साइन लिहिते. Negative sign shows that force and displacement, this is the angular displacement, त्याला displace केल्यावर theta चे मिळतं, त्याला आपण angular displacement म्हटलं इथे. This negative sign shows that force and displacement are oppositely directed here. Okay, so restoring force F equals to minus mg sin theta here. Now this is equation 1 here. Now the bob is balance कशामुळे येतो, mg cos theta, आणि तो परत रिस्टोर व्हायचा आहे तर त्याला जागेवर, तर त्याच्यावर कुठला फोर्स एक्झर्ट होईल, रिस्टोरिंग फोर्स इज ऍक्टिंग ऑन अ बॉब F equals to minus mg sin theta. But if theta, त्या बॉबला जेव्हा आपण डिस्प्लेस करू, if this theta is very small, this theta is very small, that is sin theta is approximately equals to theta here, then the restoring force F becomes minus mg into theta. If this theta is very small, if this is very small, this arc AB is considered as a straight line. समजा तो theta very small आहे, फार small आहे, तर तो arc में दिसता आपल्याला असा straight line दिसेल. This becomes straight line here. This displacement x, that is arc, becomes straight line here if this theta is very small. So here we draw. Here this is theta. Now if this theta is very small, then arc AB is considered as a straight line here. We calculate the theta here from figure. From figure, angle theta. Angle theta कसा काढला होता आपण? Angle equals to arc upon radius. Means here arc AB, okay, arc AB upon this L length. Arc AB is x by L. So theta equals to x by L here. This is equation 2. Theta equals to x by L from figure. So put here theta. So equation 2 becomes restoring force F. Restoring force F equals to minus mg into theta ला काय put करू आपण? x by L. Okay. Here m is the mass of a bob. The bob's mass m आहे. G is the acceleration due to gravity. X is the displacement and L is the length of a simple pendulum here. So here negative sign shows that force and displacement are oppositely directed. In this formula, if M, G and L are constant, M is the mass of a ball, this is constant, G is the acceleration due to gravity, this is also constant, and L is the length of the pendulum, this is also constant. Then here force is directly proportional to the displacement and negative sign is there. So from this it is clear that the restoring force acting on a ball, it is always directly proportional to the displacement of a particle from its mean position. So the motion of a bob of a pendulum is a simple harmonic motion. Hence, here we show that here the motion of a bob of a pendulum is SHM, that is simple harmonic motion. This is linear SHM. Why it is linear? Because this theta is very small here. This displacement x is straight line. So it is also called as the linear simple harmonic motion. Now we have to find the period of a simple pendulum here. So we know that what is period of a simple pendulum? The time required to complete one oscillation here. That is called as the period of a simple pendulum. And we know that what is time period of a simple pendulum? The period of a bob of a pendulum. What is time period? Capital T equals to 2 pi upon omega. आणि याला आपण फाइंड आउट केलं होतं. T equals to 2 pi upon under root acceleration per unit displacement. Acceleration per unit displacement. म्हणजे आता आपल्याला याची व्हॅल्यू काढणे आहे acceleration per unit displacement from this equation here, from equation 3. Equation 3 कुठला आपला F equals to minus mg x by n. यावरून आपण acceleration per unit displacement काढू पहिले. F ला काय लिहित असतो आपण m into a according to the Newton's second law of motion. Force equals to mass into acceleration. Here equals to minus mg x by n. Here m get cancelled. So acceleration a equals to minus g x by n. आपल्याला काय काढायचं आहे acceleration per unit displacement. So a by x, या x ला आपण इकडे आणला a च्या अपॉन ला. So acceleration per unit displacement a upon x equals to minus g upon n. काय बोलले इथे बघा, acceleration per unit displacement, this is equal to minus g upon n. In magnitude जर लिहायचं आहे तर a by x चा आपण त्याला काय लिहू g upon n. In magnitude form, acceleration per unit displacement is g by n. So we have to find here the period capital T of a pendulum, bob of a simple pendulum. So T equals to, therefore time period T equals to काय होईल 2 pi upon under root acceleration per unit displacement. त्याची व्हॅल्यू काय पुट करायची आपल्याला g by n, under root g by n. Therefore time period T equals to, इथे कसं लिहिता येईल आपल्याला याला 2 pi under root L by G. याला वरती घ्यायचं. So this becomes the period of a simple pendulum. This equation number 3 झाला हा 4. Equation 4 gives the period of a simple pendulum. Here L is the length of the simple pendulum. G is the acceleration due to gravity. So equation 4 gives the expression for period of a simple pendulum. Now from this equation 4 बघा आता काय काय मिळतं आपल्याला equation 4 वर. So time period काढणार. Time period of oscillation of a pendulum म्हणजे काय म्हटलं आपण. It is the time required to complete one oscillation. So T equals to 2 pi upon omega. आपण 2 pi upon omega ला फाइंड आउट केलं होतं. T equals to 2 pi upon under root acceleration per unit displacement आणि त्याची व्हॅल्यू काढली आपण. ती G by L निघाली अंडर रूट मध्ये. ती पुट केली. सो पिरियड becomes T equals to 2 pi under root L by G here. Now from this equation 4 we can conclude that here this period of a simple pendulum, this period of a simple pendulum 2 pi, these are constant. So the time period of a simple pendulum is directly proportional to the square root of its length. Number 2, the period of a simple pendulum is inversely proportional to the square root of its acceleration due to gravity here. Number 3, the period of a simple pendulum, the period of a simple pendulum does not depends upon its mass. मास दिसतंय का फॉर्म्युलामध्ये तुम्हाला टाइम पिरियडच्या. नाही. याचा अर्थ the period of a simple pendulum does not depends upon its mass. इथे amplitude पण दिसत नाही आपल्याला फॉर्म्युलामध्ये. म्हणजे it is clear that the period of a simple pendulum does not depends upon its amplitude. amplitude वर पण period depend नाही याचा अर्थ. These are the 4 conclusion from this time period. Okay, and this is also known as the laws of a simple pendulum. हे जे आपण 4 conclusionचे points काढलेले आहेत की the period of a simple pendulum is directly proportional to the square root of its length. This is the law of length. याला आपण law of length म्हणतो simple pendulum करता. दुसरा, the time period of a simple pendulum is inversely proportional to the square root of acceleration due to gravity. This is called as the law of acceleration due to gravity. Law of G, that is acceleration due to gravity. This is the law of mass. The period of a simple pendulum does not depends upon its mass. This is the law of mass and this is the law of amplitude. That is, the period of a simple pendulum does not depends upon its amplitude. This is all about the simple pendulum. First we show the motion of a bob of a simple pendulum is a simple harmonic motion. Then we calculate here the time period of a simple pendulum, and from this time period we conclude that here, and these conclusions are known as the laws of a simple pendulum. Okay, now what do you mean by the second pendulum here? Seconds pendulum. What is second pendulum here? त्याच्या नावातच त्याचा अर्थ आहे बघा. सेकंड्स म्हणजे काय? असा पेंडुलम ज्याचा पिरियडिक टाइम 2 सेकंड आहे. बघा, a simple pendulum whose time period is 2 seconds, that is called as the second pendulum here. So for second pendulum, time period capital T equals to 2 seconds. Okay. Here T equals to 2 pi under root L by G. हे इक्वेशन आपण घेतलेलं टाइम पिरियडचं. इथे आपल्याला पिरियडिक टाइम किती ठेवावा लागेल 2 सेकंड. कशा करता फॉर द सेकंड पेंडुलम. बिकॉज व्हाट इज सेकंड पेंडुलम हियर? द सिंपल पेंडुलम whose time period is 2 seconds. So here 2 T ची व्हॅल्यू आपण 2 ठेवली. 2 pi under root L by G. 2 इकडे आला कॅन्सल होईल. स्क्वेअरिंग ऑन बोथ साइड. इथे 1 उरला. इथे पाय स्क्वेअर याला रूटच्या बाहेर काढू L by G. Therefore here we have to find the length of the second pendulum. The L suffix ला S ने म्हटले आपण. That is the length of the second pendulum here. LS म्हणूया आपण त्याला. So LS equals to G upon pi square. This becomes the length of the second pendulum. Equation 5 gives the length of the second pendulum should be equals to G upon pi square. If we know the value of this acceleration due to gravity at that place, then we can find here the length of the second pendulum. By using this formula, Ls equals to G upon pi square. This gives the length of the second pendulum. Okay. From this periodic time, we also calculate the frequency. इथे frequency पण आपण काढू शकतो. Time period and frequency. If n is the frequency, 1 by t असतो. Frequency म्हणजे reciprocal of time period. Because what is frequency? The number of oscillations performed per unit time. This is called as the frequency. So n equals to frequency. n equals to 1 by t आणि 1 by t आहे. या फॉर्म्युलाला कसं लिहू आपण 1 upon 2 pi under root G upon L. This gives the frequency of a simple pendulum. Means this is all about the simple pendulum. What is second pendulum here? In simple pendulum आपण बघितलं आहे की what is length of the simple pendulum. याला आपण length म्हटलं. What is periodic time? Time period काय आहे त्याचा? We show here the motion of a bob of a simple pendulum is simple harmonic motion here, and also here the second pendulum and the length of the second pendulum. So this is very important here. Here the question is like that: derive an expression for period of a simple pendulum and hence show that the motion of a bob of a simple pendulum is a simple harmonic motion. Thank you very much. So keep studying and happy learning.